2.2. We'll start picking up kind of just after the addition subtraction stage, since that's a little bit easier. But we're going to go through the show you know now. Okay, so Owen, what did you put for your estimates here? Okay. Okay, was -4, good. And then what'd you get? -2, all right. And then when you actually calculated, what was your actual calculation? Okay, go ahead and do that. We'll do the estimate for Evan. What'd you get for your estimate over here?
-1.
Okay.
-4.
Okay, and then what did you get for that?
-3.
The $1 you borrow 4 more.
It's like when you're stealing my money.
It's a bigger number. It's 5.
Oh, it's
5. Okay, so -5. All right, do you have the calculation? Okay, go ahead and get that done. You got the calculation, Aiden?
Yeah.
Sure, what's that?
Well, I just did 1.25 plus 3.55, and I threw a negative sign in front of the answer, and that's 4.8.
Okay.
Yeah,
Yep, -4.8. So you knew that you knew the integers were combining, so he combined them through a negative in front. That's perfectly fine. So we talked about just before about number sense. Got a calculation here on? -2.86. All right, perfect. Okay. All right. All right, so moving forward here to the multiplication division. Okay, so we'll estimate then calculate. So with these, they've kind of mixed up going between tenths instead of always going with whole numbers. So, try to like 0.45, they're going to make 0.5. -1.2, they're going to make -1. Okay, half of a -1 is a -1/2. So you'd have -0.5 here. Because 1 times anything's itself, right? And so that is kind of why that comes out that way. Now with division, it's a little bit different. So they estimate they went to 0.2, and then we'll go by -2. Now here's what I want you to think about. When you're dividing a whole number by a decimal, you want to think about like how many times does 0.2 go into 1? So how many times does 20 cents go into $1? 5. Okay, but we don't have $1, we have $2. So it'd be 10, right? Because 5 times 2 is 10. So this would be negative divided by a negative is a positive, so we'd say about 10. Everybody see what I'm talking about there? So you take the decimal and think about how many times that decimal go into one hole. How many holes do I have? Okay, this decimal goes into a hole 5 times. I have 2 holes, 5 times 2. Okay, little mental math. Now we actually do this. Okay, want to bring this up. So this one, here's the calculation in the calculator. It was actually 9.2, so those are fairly close, which is good. We're going to go ahead and use paper and pencil for the multiplication one. So you need a little refresh on how to do that probably. So remember, when you're doing multiplication of decimals, you multiply it just like a normal multiplication problem. So you're going to go 2 times 5 is 10, so you put a 0 here with the 1 up top. 2 times 4 is 8, plus the 1 is 9. Okay, add a 0. 1 times 5 is 5. 1 times 4 is 4. Now you add them straight down. 0, 9 plus 5 is 14. Put a 1, 540. Now, how do you figure out, who remembers, how do you figure out where the decimal's at now? Yeah.
based on your estimation.
Okay, you could, but there's actually a little bit like a direct way. Owen? You're close. Olivia, do you remember? Correct. So you go right here and you say, okay, there's 1, 2, 3 numbers after the decimal. So that means I go over here and I go 1, 2, 3. So it'll be right there. 5.540. Does that make sense? And it's a negative. Okay. All right, good. Okay, go ahead and try these ones here. I want you to see if you can do the first one without a calculator. Okay, you can go ahead and use a calculator for the calculation for divide here, but see if you can do that one without a calculator like we just did. All right, so what did you get there, kid? What did you change the estimates to?
0.6.
Okay, so -0. Oh, did not want to do that. right, so negative 0.6, and you said 6, right? Okay, and then what was that approximate? 3.6, good. And then when you multiplied it, you had 0.6 times 6.1. Okay, and then what'd that look like? 3.36. Okay, good. All right, so maybe you'd line it up. So you do everything, and there's 2 decimals, so you whatever you got, you'd move it over 2 decimal places, just like we did in our previous problem there. Okay, so Nolan, what was your estimate for B?
Just 2.5 divided by 2.
Okay, negative 2.5 divided by 2, and then what'd you get?
1.5,
Negative 1.5?
yeah.
Okay.
Or 1.25.
1.25, okay. And then what was the actual calculation?
It's negative 1.6.
Okay, good. All right, perfect. Okay, on the final turn here. All right, so apply operations rational number decimal form. The temperature at blood reserve and algebra is decreased by 1.2 degrees Celsius an hour for 3.5 hours. It then decreased by 0.9 Celsius an hour for 1.5 hours. What was the total decrease in temperature? Okay, so what we're going to do is, we know the time periods it happens is, it does it for 3.5 hours something, and does something for 1.5 hours. So temperature decreases for negative 1.2, and the other temperature is going to be, gosh dang it. The other one's going to be the, what is it? 0.9, thanks. I just didn't want to move up. Okay, so negative 0.9. Anytime it says decreases, that means that you're dropping. Okay. All right, so then we know 3.5 hours is negative 1.2, so then we go 3.5 times negative 1.2, you get negative 4.2. That's the drop for the first 3.5 hours. Okay, then for an hour and a half, it goes negative 0.9. Okay, what's 1.5 times negative 0.9? Is it negative 1.35? Somebody calculate that for me, make sure. What's that? Oh.
What did you say?
1.35?
Yeah,
Okay. All right, good. Then we want to figure out the total decrease, so we're going to add those up. So we got negative 5.55. Okay, good. Evaluate one expression. The expression shows the total temperature decrease. So let's see what they're doing here. So the method 2 is just kind of putting it all together with kind of almost like ordered operations, but shows a 3.5 times negative 1.2, 1.5 times negative 0.9. So they're just doing order of operations setup. So here was the first time frame. Here's the second time frame. Since these are multiplied in order of operations, we're going to do these first without the brackets. I just bracketed them so you could see it clearer. Okay, and then because you have the plus sign in the middle. So then it's just showing you're just going to do your same thing. Okay, so we just have the negative 1.35 and the, sorry, what was this one again? What was the first one again? The first total? 4.2, thanks. Okay, and then we get the negative 5.55. Okay. All right. So what was the average rate of decrease in the temperature? And so to figure out what the average decrease in hour was, you're just going to take your total decrease divided by total hours. Okay, so total decrease divided by total hours is going to be 1.11. So the average was negative 1.11. Okay, and that's just simple division there. Not a big deal. And we'll go ahead and finish up and do this last show you know together so that we can get you guys going here. Okay. All right. So the last one. A student did an experiment where the temperature went from 20.8 degrees Celsius to 50.4 in 10 minutes. How much did the temperature change per minute? So we have to figure out the total temperature change and then divide it by what? 10, right? Because we're finding out how much per minute. So we go 50.4 minus 20.8. Okay, so that's going to be 29.6 Or no, not 29. Yeah, no, that's right. 6. So that's the change. All right. And so now we're going to do is we have total number of minutes is 10. And so we're simply going to go 29.6 divided by 10, which is going to be 2.96 per minute. We just average it out over time. Yeah. Simply just move it over. Yep. Good. All right. So that's it for that one.